So hello everyone. We are gonna be learning what is meant by the sight distance in this video. So what is the sight distance? Sight distance is the actual distance along the road surface with a driver sitting at a specified height can see the object either moving or stationary on the road surface. That means suppose this is the curve, okay, and this is an object and the vehicle is coming from this portion. So this length is known as the sight distance, and this length should be along the road surface. Basically, the main idea, main definition is like this, okay, not more than that. And this simple, this is the sight distance. So there are this object may be stationary, like it can be a tree or some obstacle, or it might be a moving vehicle in opposite direction. So it might be stationary or it may be moving. So that is known as the sight distance. So another the type of the sight distance is the stopping sight distance, overtaking sight distance, intermediate sight distance, headlight sight distance, and sight distance at intersection. So let me explain all the sight distance in very simple way. So what is stopping sight distance? So basically stopping sight distance means this is maybe okay, the driver is moving like this is the driver, okay, and the driver see the obstacle here, and how much distance this the how much distance should be provided between the vehicle and this obstacle, so that the driver can apply the brake and it will not collide with the obstacle. That means, well, I'm providing this distance, the distance between the, okay, the driver has not seen this obstacle till now here. Up to here the driver hasn't seen the obstacle. After reaching here the driver sees the obstacle, okay, and he will process it. Okay, that is the obstacle. He clarifies that what I am looking is an obstacle. Now I need to apply the brake. There will be some span of time on realizing what is obstacle, and on reaching out to a conclusion of applying the brake, there will be a span of time, okay. And after that the driver starts to apply the brake, all right. And the driver, after this distance the driver started applying the brake, and the driver will be reached up to this distance, and his brake works up to this distance, and the vehicle will finally be in rest condition, all right. So what is the distance that is provided, so that after seeing the object the vehicle can apply the brake, and it will safely be stopped at some distance without colliding with the obstacle, is known as the stopping sight distance. Simple as that. If the vehicle apply the brake from here and it collides with the obstacle, then this d is not an accurate not an this is not an stopping sight distance. The design is very bad, okay. So the next one is the overtaking side distance. What is overtaking side distance? Simple. Overtaking side distance is, well, consider this as a two-lane road, and the slow-moving vehicle is here, and the fast-moving vehicle is here, and another vehicle is coming from here. So how much distance should this be provided, so that the vehicle can overtake this and reach here without colliding with the opposite vehicle? And that is called the overtaking side distance. Simple as that. And what is the intermediate side distance? So intermediate side distance is basically sometimes intermediate side distance can be basically, sometimes there will be one lane road, okay, and the vehicle moving from, okay, so there is a one lane road, all right. And suddenly this vehicles sees an vehicle coming from the opposite direction, but obviously it's a one lane road. So you need to apply the brakes so that you will not collide with this vehicle. And this distance is known as the intermediate side distance. And basically intermediate side distance is taken as two times the stopping side distance. In general it is taken as two times the stopping side distance. So okay, fine, we understood up to here. And next one is the headlight side distance. What is headlight side distance? It is the distance that the driver can see from the from the headlight illuminance. That means the headlight will be blown, and the headlight will obviously illuminate the object in front of it, and how much distance the illuminance of the headlight is there, and how much distance will the driver see from though the illuminance of the headlight is known as the headlight side distance. And the next one is the side distance at the intersection. What do you mean by side distance at the intersection? So let me consider this road, and there is an intersection like this, and suddenly another vehicle comes from here, and the vehicle coming in this direction had to stop due to this vehicle coming from here. So how much distance should he be covering before stopping this intersection would be the uh, what he said, intersection side distance. Basically these five are the types of the side distance, and it is very simple. Okay, so stopping side distance is the minimum distance required within which the vehicle moving at a design speed can be stopped without colliding with a stationary object on the road. I explained earlier. And what will be the factors affecting this? So first one is the speed of vehicle. The more the speed of the vehicle, the more the stopping side distance will be required, because it will take a long time to come to a rest, right? And the next one is the efficiency of the brake. Like if the brake efficiency is 100%, that means you apply the brake and your vehicle stops right there, then the stopping side distance will be less. That is the reason. Okay, and another is the frictional resistance between the brakes. What is frictional resistance? If the frictional resistance is more, then the stopping side distance will be less. If the frictional resistance is less, that means the vehicle will take a long time, the frictional resistance will take long time to make the vehicle come into the rest. That's why this will be more. If the frictional resistance is more, then stopping side distance less. If the frictional resistance is less, then stopping side distance is more. And another is the gradient of the road. Like in ascending gradient, the grade will also oppose the flow, oppose the movement of the vehicle. That's why stopping side distance will be less in this case. But in case of descending gradient, the grade will be in support for the vehicle to move forward. That's why the stopping side distance will be more. Simple as that. And this is typically explained by PIEV theory. That is perception, in what is that, intellection and emotion, and the next one is volition. So basically we explained the stopping side distance by this theory as well, and it is a very important theory. First one is the perception. Perception means that the driver realizes that driver feels that something is in front of him. Like if we are driving, and another, we see and we see something here. Okay, we don't know what exactly is that, or we are not sure that is something, is that even an object, we are not even sure about it. But we feel like there is something in front of us. And the time that we feel about something is in front of us is known as the perception time. Okay, and the what is the intellection time? Intellection time is we identify the object. That means if I saw a signal showing the red light. Okay, so I am moving in a vehicle, and in front is the signal showing the red light, but I don't know what is that. I don't even know that this is a signal, but I know that it is something. But I'm not so sure about it, that it is either a signal or anything, but I feel like it is something, is known as the perception time. The time that I feel is known as perception time. And after moving a bit forward, I get to know that, well, I identify the signal. That is okay, this is a stopping side signal, that is a red light. I identify it. And the next one is what I should do, what is the appropriate decision for the situation. So the next one is, okay, I start to apply the brake. What might be the decision? So I I will be finding the appropriate decision for the situation. So if I saw a red light, then what will be the appropriate decision? To apply the brake. So to think about the time required by me to think about the appropriate decision is known as the emotion. And after that, I identify the problem, I identify the appropriate decision, and final is the final action to be required, and the how much time I will be using from shifting my leg from accelerator to brake is known as the volition time. So that's why we explain this stopping side distance phenomena in this four way. So the stopping side distance should always be less than side distance. We know that, because if this is the side distance, that means I explained earlier as well, right? This is if this is my vehicle and this is the obstacle, and the distance between my vehicle and obstacle is d, that is side distance. then my stopping side distance will be above here, d dash. But my vehicle should stop beyond the stopping side distance, so that there won't be any head of collision. All right. So intermediate side distance is 2 times the stopping side distance. And what will be the driver's reaction time? What will be the reaction time is explained by my PIEV theory. Okay. So for perception, intellection, emotion, and volition, so what? How much time does it take for me for this four phenomena to happen? And it will be 2.5 second. Generally, it will be 2.5 second. But if it given in the question, then we will be doing that with the value which is given in the question. Okay. So SSD analysis is done by lag distance and braking distance. What is lag distance? Lag distance is the distance covered by me in this 2.5 second. That is distance covered by me while I perceive the object, while I intellect the object, that is identify the object, while I think about the appropriate decision, and while I switch my brake from accelerator to brake. Switch my leg from accelerator to brake. So total time in this 2.5 second also I'll be covering some distance. So that distance is known as the lag distance. And another is, okay, I'm covering this distance in 2.5 second. So now I apply the brake. So how much time will take my vehicle to stop after I apply the brake is known as the braking distance. Okay. So what will be the reaction distance covered during the reaction time? That is lag distance equals to B into T. It is very simple. If we convert this v is in meter per second, and if we convert this b into kilometer per hour, it will be 0.278 into v into t. V is in kilometer per hour. And what is the braking distance? Braking distance is the distance covered by the vehicle until to come stop after application of brake. So what is the F is the frictional force developed. The vehicle will be developing a frictional force, and this is length. Okay. So L is the braking distance. That means this distance is the braking distance. And W is the weight of the vehicle. Weight of the vehicle is W. So what will be the work done by the friction? Work done by the friction will be frictional force into length. And what is frictional force? W into F. We know that mu R. This R and mu. So W into F. R will be equal to, yeah, W, because RA plus RB equals to W. We know that, right? So W into F into L. And initial kinetic energy of the vehicle. What will be the kinetic energy of the vehicle? mv square by 2. That is W by G, V square divided by 2. It is the initial kinetic energy of the vehicle. And final kinetic energy will be 0 because I apply the brake, and after application of the brake, the kinetic energy of the vehicle will be 0. That's why final kinetic energy is 0. So we know that work done equals to change in kinetic energy. So F into W into L equals to W V square by 2G. So L equals to B square by 2FG. And I change this b meter per second into kilometer per hour, then my final output will be b square by 254 f. And if the gradient is also given and efficiency of brake is also given, then I assume it as f plus minus n means the gradient into efficiency. I will be doing like this. This is generally considering the gradient and the efficiency of the brake. My last formula will be like this. The first one is the lag distance and the second one is the braking distance. Okay. Here the efficiency should also be there. Okay, I have written here like that. So in this condition, this F is the longitudinal longitudinal friction. Okay. So the value of F will be 0.35, near about 0.35. The range is given here, but we generally take 0.35. Don't be confused about F in the previous case where we used to assume 0.15. This is the lateral coefficient of friction. This is the longitudinal coefficient of friction. That's why F equals to 0.35. So please don't be confused about it. Okay. And in the single lane two-way traffic, so single lane two-way traffic, then this is the vehicle and another vehicle will be here. If this is the moving vehicle here, then our value will be 2 times the SD, that is the side distance. And in case of the one-way traffic, SSD will be look, you can say that okay, let me explain this a bit clearly. So look here, in the single lane traffic, this is my vehicle. Okay. And I see an object, and my stopping side distance will be only side distance like this. All right. But in case of a double lane traffic, okay, this is my vehicle and this is a double lane traffic and another vehicle is coming here. Well, for this another vehicle will also be seeing my vehicle and I'll be also seeing the another vehicle. So my stopping side distance will be SD and his stopping side distance will be SD. So I have to multiply this SD divide to into 2. If let me be clear, if they are moving with same design speed, same velocity, then we'll be doing 2 into SD. But if they are moving with different velocity, then I'll be summing up this SD and this SD. That will be SD1 plus SD2 and it will be the stopping side distance. That means SD1 plus SD2. Okay, like this we are explaining this phenomena. So another one is the overtaking side distance. So overtaking side distance is the minimum distance required by the vehicle or driver to overtake a slow moving vehicle ahead of it that is traveling in the same direction uh, safely against approaching traffic in opposite direction. So we can see here this is a two-lane way and this is a slow moving traffic and this is my vehicle which is in fast moving condition and I will reach here after overtaking, but the vehicle will be reaching here after overtaking. This is the lane. Okay, let me make it a bit clear and this will be the boundary and the red one is my vehicle and the yellow one is the slow moving vehicle. Okay, and the green one is the opposite vehicle. Okay, so right now overtaking side, we explained about the overtaking side distance is it is the minimum distance required by the vehicle to overtake. Okay, so what will be the assumption in this overtaking side distance? So first assumption is slow vehicle travels at uniform speed. Uniform speed will be there. Slow vehicle will traveling at uniform speed and the fast vehicle reduces its speeds and follows the slow vehicle as it prepares for overtaking. Like here it I will be coming at very high speed, but I will be reducing my speed and I'll be maintaining my speed according to the speed of the slow vehicle. Okay, so the second condition is this and the next condition is driver requires short time to perceive the situation, react and start acceleration. That means I reached here and I'll be requiring about 2 seconds so that I can see this vehicle, I can see this opposite vehicle, and I can start the acceleration so that I can overtake this slow vehicle. So the reaction time for me will be 2 seconds, near about 2 seconds. This is not exact 2 seconds, but it depends upon the driver, But it is average. It will be 2 seconds. And another is overtaking is accomplished under a delayed start and early return. That means I start overtaking at a very delayed condition because I reduce my speed and I make my speed equal to the speed of the slow moving vehicle, and after then only I accelerate my speed and I overtake the slow moving vehicle and I reach in front of the slow moving vehicle at a very fast pace. That's why overtaking will be accomplished in early return and travel during the actual overtaking operation is uniformly accelerated traffic. For this portion, this red tracing line, this right now I'm doing with blue line. So for this tracing line, the acceleration will be uniform. If I if I have to overtake the slow moving vehicle, then I need to accelerate my vehicle, yeah, right? So my vehicle acceleration will be uniform during this red path. That's what it is said in the assumption. So now I need to so now I'll be analyzing my OSD, that is overtaking side distance. So I visualize this diagram in here as well. I visualize this diagram. This is A1 condition and A1 condition will be a bit backward. This is A1 condition. I'm at very high moving vehicle and after then I reach in reaction time I reached to this portion and after this portion I started accelerating so it will be an constant uniform accelerated motion. And v1 is staying here and v2 will be here, and c1 is coming at this velocity, and after he saw me, it no, and after I overtake this vehicle, the c2 will be in this distance. Okay, so this is explained here. So the distance between this is called d3. The distance between I'm coming at a full-fledged speed, and in the reaction time I cover the distance d1, and after the reaction time I started overtaking. That's why the total distance covered is d1. Yes is the spacing between my vehicle and the slow moving vehicle, and b is the distance covered by the slow moving vehicle during my overtaking time, and d2 is the, and again s is the spacing between the my vehicle and the slow moving vehicle. So a1 a2 portion of the fast moving vehicle at different time interval b1 and b2 is written here. bb is the speed of the slow moving vehicle, b equals to design speed. So approximately, if we are given as design speed as 50 km per hour, then the bb, that is velocity of the slow moving vehicle, will be 50 minus 16, that is 40 30 4 km per hour will be the bb, if not given bb. Okay, if bb is given, then we use the bb. So what will be the OSD, overtaking side distance, would be, I need to cover d1 distance, I need to cover the d2 distance, and for safety the c1 vehicle should cover the d3 distance. If it covers more than this distance, then our vehicle will collide. So for safety, the d3 should the c1 and c1 c vehicle should cover the d3 distance. Okay, so the first one is the d1 distance. D1 distance is the distance traveled by the overtaking vehicle, that is me, during the reaction time, and s is the spacing, which is given by this empirical formula, that is 0.69 bb plus 6.1 meter, and b equals to bb into t. We know that t is the overtaking from a2 to a3. Look here. Okay, so I take t time while I overtake from position 2 to position 3, and in that t time the b vehicle will cover the distance b. That's why b equals to velocity of b vehicle into t. I am doing like that. Okay, and t is the overtaking from d to the dt, and d2 is the distance traveled by the vehicle a during the actual overtaking operation. That means actual overtaking operation, how much distance do I cover? S distance, b distance, and s distance, that is I covered d2 distance, that is 2s plus b. B distance is covered by me, so I will be covering this b distance, and in that distance my I'm using the equation as s equals to ut plus half at square. Okay, so I'm covering d2 distance, and what will be my velocity? My velocity will be bb, because I'm moving with the velocity of slow moving vehicle. So my velocity, initial velocity, will be bb. As you can see here, my initial velocity is bb. As in assumption, I have stated that I'll be reducing my speed to the velocity of the moving vehicle b. So that's why bb will be my velocity, and bb into t is the time, and 1 by 2 at square. Okay, and from here we came to know that t equals to, look, d2 value we keep it as 2s plus bb into t, bb into t, and bb into t will be cut out, and t will come as 4s by a, and a will be in meter per second square, meter square per second, meter per second square, what I'm writing here. So if t a is in kilometer per second, then our formula will be t equals to 14.4. This is only converting into kilometer. Okay, so this is the case right here. And what will be the distance covered by d3? I haven't explained what will be the distance covered. So d3 is the distance covered by c vehicle while I'm in a overtaking operation, that is in time t. So what will be the d3? That is design speed into t. Okay, and if the design speed is in kilometer per hour, I need to multiply this by 0.278 into v into t. Okay, right, like this we can do, and I'll be adding up d3, d1, and d2, and my final overtaking side distance will be d1 plus d2 plus d3. So after this, we'll be doing some numerical regarding the stopping side distance and overtaking side distance. The next one, the three intermediate side distance, will be 2 times stopping side distance. Headlight distance will be near equal about stopping side distance, and intermediate side distance will also be equal about stopping side distance. So I explained you that what this actually means by these three stopping side distances, and you can further read in a book which is available, and and in the next video we'll be doing the numerical for this question.